Good. Whoa. Morning? Is there echo there? Oh, that's why, because I have my microphone or my headphones in the background. Good morning. It's actually good afternoon for me because it is 1 p.m. in Toronto, Canada. Let me know in the chat if folks can hear me all right or I need to adjust the audio. While we wait for people to tell me whether or not the audio quality is good. We can hear you fine. All right. We once again have the Mary Berry Buble. Freaking fantastic. Here we go. It's actually not that good. It's probably not even in the top 3 to 5 flavors. I think we finished 4 or 5 on stream yesterday, and then I had one in the evening, and they come in packs of 12. So we got 6 more to get through today, and honestly, pretty freaking happy about how yesterday went. So happy that I was like, let's just do it again, because I don't think I could have waited 1 or 2 weeks to continue working on this. So we're going to speed run a 5-minute recap of what we did yesterday, and then we're just going to hop into things. And I also have a donut that I'm going to eat at some point. But 5-minute summary. So there are a bunch of array languages, APL, BQN, J, and there is a esoteric array language called Jelly that is based on the J language. If you haven't gone and starred this repo, you should go start it. And it is a highly, what I would call, impenetrable language. I remember the first time I saw this, and this is the Hello World program. Note that this is like not actually, it's compressed, but like maybe don't do this because you're going to scare people away, including me. But over time, it came up a couple times on Arraycast, one of my podcasts. Plug for all this stuff, subscribe to my channel. If you're missing the content from the channel, I've got 2 different podcasts, ADSP and Arraycast. Anyways, the Jelly language has come up a couple times, and it's been mentioned that similar to Weewa, Jelly does not have overloaded functions. So in APL, BQNJ, all the digraphs, all the symbols have both monadic and dyadic definitions, whereas Jelly and Weewa do not. And so at some point I said I was going to go and become an expert in this language. I never got around to doing that until this weekend. And yesterday we built up basically a small Python script that just wraps the Jelly executable in a subprocess. And then what we have done, we can go take a look at the code now. Actually, I should say it was Evan who, I'm not sure if Evan's in the chat. I think they're I can never remember the usernames. It was something Sage or Sage something. They went and I did like the first A through H of these. And actually, we should go to the Jelly beans. So Jelly is the language, but there is I guess it's on my README, a Jelly interpreter that Adam, I actually thought that Dennis, the creator of Jelly, did this. Apparently he did not. Adam, one of the panelists on Arraycast, but probably more importantly, he is the programming language lead at Dialog APL, the company, or Dialog Limited, the company that makes Dialog APL. He went and created this interface where you can basically type things in. So for instance, R is iota, and if we type in 10 and then we go to the run tab, you'll see that we get 1 through 10. However, I mentioned yesterday this is a bit cumbersome because it's a really good website. It's much better than just having an executable. So this is kind of a stepping stone to what I wanted. But I wanted something where I wouldn't have to type range and then hover over this, and it's very hard for the viewer because this is basically just what do you call it, a active bubble or something like that. It says inclusive range. I basically wanted to be able to type, iota, and then in the background have some script, convert this into Jelly, and then we can play around and visualize the combinators and chains, which we talked about yesterday. So that's basically what we did. Evan went and after I had done A through H, he added the rest of these, which is freaking awesome. Only problem with that is then I don't know what actually the names of these are. So at that point, we had our script going. We fed it to ChatGPT. I mean, ChatGPT actually, wrote most of the script for us in the first place. And we just made some modifications to it. And then we got ChatGPT to do these amazing auto-completion. So now, while we're adding the dyadic functions today, if folks want to create PRs and help add these, I don't actually need to know the names of these. I can just, play around. Absolutely fantastic. And the most interesting, and we also have this trace. So for instance, if we do, what do we want to do? Iota, we want to do iota, what is, I guess, sub, there's a sub one, odd, sum list, and then we'll do this for 10. So this will give us the trace, right? First, it's a iota sequence to 10. Then you subtract 1 from each one. Then it's a Boolean predicate. I guess all predicates are Boolean. Text checks whether it's odd or not. And then we just sum this up. And so at each stage, this is technically the final translated Jelly expression. R apostrophe B over top S. Which obviously means nothing to me because I don't actually know Jelly. And on top of this, we have started creating this chain visualizer that basically tells us the type of chain that it is. And in this case, because we just have a bunch of monadic functions, 4 of them to be exact, we end up with a 1-1-1-1 chain, and a 1-1 chain within a chain is a B combinator. This actually is wrong, though. We're going to have to fix this. So this is a bug. And no worries if you're running late. You can ask questions at any point. Happy to answer them. Actually, we should go fix this right now. Anyways, that's kind of it. So what's the goal? I have a to-do list here. Yeah, we need to fix this. We need to add dyadic syntax for dyadic stuff. But basically, I want to, fill out the dyadic functions and add support for dyadic combinator trees, and then maybe get to multi-chains. And also, more importantly, we have to come up. We have to. I'm so excited about. I honestly haven't stopped thinking. I got off the stream last night. It was 8 hours straight. It was 8 p.m. I think I took like a hour break. Then I went to the gym for half an hour. Then I went to the sauna. And then I don't think I got to sleep till like 1 or 1:30 because I just couldn't stop. I couldn't stop thinking because I think I've honestly solved. I've solved Jelly. And it's very novel what Dennis has done. It's very exciting. And it also in the context, like we've got dialogue APL, we've got cap, we've got BQN is basically just it's just dialogue. It's we'll just, when I say APL here, what I mean is dialogue APL. This is what this is. Cap is like it's like APL but better, and then Jelly is like, it's like wow, and each of these, yeah, we'll talk about it. But the point is, we have to create some kind of visualization for these chain precedence tables because they are harmful. They are extremely harmful. And I say that with like no offense to Dennis. He's done great work here, but the chain the chain precedence tables that he has for monadic and dyadic chains are so confusing. And let's actually, so we'll come back and we'll fix this in a sec because that's broken. But if we come back to this and we go to the tutorial, so like I've basically, hello Alexa. So this I've solved it actually, and so we're gonna look at this table, but really we're gonna look at my table because my table is a better version of this table, and yesterday I came up with this. The final two columns in this table are incredibly important. So there's the initial combinator. So when you have this chain 1 1 1 1 1, the initial combinator is just whatever you parse first, and then the subsequent combinators is just anything after that. And what's confusing here is that really these chain types, when it's the initial combinator, it's just the chain type you see here. But when it's a subsequent combinator, it's the chain type prefixed with whatever the arity of the function that was returned by the previous thing that was evaluated. Now that sounds very confusing, but it's actually very straightforward. So like if we go back to this example that we looked at yesterday. So this is a 2 1 2 1 1 1 2 1 2 1 1 2 1 1 monadic chain. And so there's a precedence table that we look at. So basically we try and match. We've just got this sequence of numbers here, and we just try and match. And the higher it is in the table, the larger the precedence. So obviously because this is a 2-1 chain at the beginning, we're going to match this immediately. And this is the S combinator. And actually something we should do, we also got to do that, is I want to build in a little like shortcut version of this into this program so that you can just hit some command and then like ASCII display so that we don't need to constantly keep back switch. Because I have all this stuff memorized in my head, but I understand most of the viewers, if not all of you, do not. And we also got to rearrange this because yesterday we added delta and sigma, but yes, I like S being at the top because S is a fundamental combinator, but it doesn't really matter. We should put it down here with sigma, D, and delta. But the point being here is that on the initial combinator, you match here. But then, I mentioned this yesterday, but I'm trying to drive the point home, is that you evaluate this, and actually, wait, what the heck has happened here? Something's gone wrong. This should be, actually, we got to fix this right now. What is going on here? I only made a couple changes yesterday, so it shouldn't. If initial call, S if initial call. So where is... Yes, that's a bug that I introduced yesterday. When I was... So there was... If you were watching the stream yesterday, I kept on commenting that, like, did I mess up this cprint function that I added a new line Boolean to? Yes, I did. And I don't know why I didn't notice it. And when I was refactoring that, clearly I broke this. So if we clear this... So actually now let's go back... Now this is correct. Yes, BBB. Although the alignment's still off a little bit. And if we go back to this one... and actually, I just want to commit that right now. Bug. Small fix. All right, we're back. So, you go to your table, 2 1s at the top, and you evaluate this as S. because that's the rules. But what S forms a unary function, which means that when you are going to proceed in evaluating this monadic chain, you basically pop off these two values and then push onto the front of it a 1, because S is a unary function, or S forms a unary function, I should say. And then you evaluate the next thing. So really, if we break this down alternatively, first what happens is we evaluate this, and then this becomes, so we pop that off, and then we kind of, I don't know how to really visualize this, we're popping off, pop off, and then push on. And then here we go back to our, and so now, and then this is the initial call, or the initial combinator. But then everything after this is subsequent. And so the trick is for the subsequent ones is that, actually we want to go here. The subsequent ones, you're no longer matching on this quote unquote chain type. You need to prefix, I think in almost all these cases, a 1 to the front of this. So on the initial combinator, you're matching 2 1, 2 0, 0 2, 2 and 1. After that though, you're matching on 1 2 1, 1 2 0. Actually, I don't know about the 2 0 and I think that is actually right. 1 2 0 and 1 0 2. And then 1 2 and 1 1. And then that makes way more sense in my head, because like how do you get phi? It's like basically you have this reverse stack where you're popping off the front and pushing onto the front, and each of these combinators consumes a certain number of functions. A fork consumes 3, S consumes 2, B consumes 2, and all of these return you a unary function. So you're always pushing 1 back on. And so you just repeat this process. But the confusing thing is this chain type 2 1, 2 0, 0 2, 2 1. It doesn't mention anything about that, like pushing on a 1 and matching for it just has this table that you have to, like, implicitly this V thing, it's just kind of confusing. I don't know. Maybe this makes more sense to people. I don't know. I think it makes more sense thinking about it in the context of, like, what are these combinators actually? Anyways, that was way more than 5 minutes. That probably didn't make sense to anybody, but it makes sense in my head. And hopefully, once we have this visualization, it will make a lot of sense. If you've got questions, feel free to leave them in the chat. But yeah, we are going to do the first two things first. So first thing I want to do is the easy one. Currently, right now, all we have support is for monadic chains. But I want to have support for dyadic chains as well, obviously. So the way we're going to do this is we are going to so right now we just assume that the last argument is the last, I guess, string, usually a numeric value, is your argument. Now what we're going to do is we are going to we are going to split on this. Actually, let's do this in IPython 3 first. And so say we have iota rev sum, and then I want 10. So if I do split on colon, yeah, so that's exactly what I want. And then converted expr dot strip and then dot split and then args is going to be a list of 1 or 2 elements. So what is the nicest way of I mean, I guess you can just I wonder actually if it's nicer to do it like this. S dot strip for S in. Hello, Ven. And then where does args? Args comes up. What is head of from enum import enum? And class we need to change the type to chain arity. Chain type equals chain dot matic if the length of args equals 2, else, actually wait, 1 else chain dyadic. And I think you can, this is the beautiful thing about Python. You can just go chain dot chain type. You can just stringify this, right? Right, because we now need to put a colon. Yeah, and what happens if we to do this should support the dyadic case why does it do that? Is args not a list? Args is not a list. Why not? Right. Args is just a string that needs to be split. I mean, technically they both need to be split, right? So and then when we split, we don't need to split this here then. There we go. Okay. That works. I mean, it's kind of irritating. ChatGPT. Is there a shorter way to do this in Python? Yeah, no. It's all right. All right. Well, and actually, so now if I put 1010, oh, and also it's not exactly what I wanted. How do I print the name of a dot name? Don't even need the string. God, don't you love Python? Monadic chain, and then I do this, and look at, now it's a dyadic chain. All right, so technically it's still not evaluating because we're just passing in the first argument. But okay. All right, so I guess the next thing to do and actually to add to our to-do list. So and then modify, run Jelly to support that. We also want to add the 20 and 0 to so let's see, what is actually all right, let's comprehensively fix the indenting. Actually, let's get rid of that. So also, arguably, we should put little dots here. I'm also not sure that this is the best representation. But it's the one we have for now, so So yeah, it works. S should be 3, 5 should be phi should be 5. B should be. So what if it's a it's going to be 2 1 is going to be S. And so if we just square this, this will be a 2 1 1 chain, which will be an SB. Whoa. Why? That's a bug. I mean, this is all correct, but this is wrong. So why is that? Let's figure that out. Guess we should also consider adding some unit tests at some point. But, you know, uninteresting for now. We're just having fun here. So, right, the reason is because we introduced a bug when we changed this. Xper now never needs to be -1. So actually we should make sure. Yeah, I think that fixed it. So yes, as I expected, this is a 2 1 1 chain, aka a SB, but basically S should be 3, B should be 3, phi should be 5, but anytime it's a subsequent one, it's always going to be at least one more. And it depends on the length of the previous combinator. So if it's a phi followed by a phi, then it's going to be like 5 plus 2 equals 7. But if it's a phi followed by or preceded by an S, it's going to be a 5 plus 1. All right. So using that logic, we need to go to draw. And our combination, and also where this is a pretty disgusting function with a lot of redundancy, we're gonna fix that. Don't worry. And so the single tree uses indent. And width to draw this. So, I mean, at the moment, the indent is always correct. It's the width that we need to consider. So we're going to need to pass along the previous width, which is going to determine the adjustment. In fact, we might not even need the previous width. We might just need to pass the adjustment. Width adjustment. So on the initial call, it's obviously going to be 0. And actually, we could kind of get rid of initial call and just check if the width adjustment should we do that? Initial call equals width adjustment equals 0. Why not? Why not, folks? And then anytime we call combinator tree, you know, we're going to need to pass a value here in a sec. That's kind of nice though. Depth, width, adjustment. So this is just going to take an int that is the current width. And based on that, so when it's 3, the width adjustment should be 1. If width equals, I mean, there's probably a formula for this, so we'll because B should be here, but we want it to point to one more. C4 Tubo asks, in the case of +10 or any dyadic taking only a single value, show the W combinator first that it is implicitly inserted by Jelly before the actual becomes a 2-1 that feeds to the S combinator. So, I mean, I do show the W combinator. Right, that's not a dyadic function. So this is the W combinator, but what's interesting is that we don't actually need to show the W combinator in this case because the W combinator is implicit inside of the S. And actually, what's the best way to go and, I mean, we could go bring up my master's thesis, but that's 100 pages. So instead, composition intuition, really? This is what so I downloaded a new browser for the purposes of streaming. So now it doesn't know who I am. So this graphic is taken from my master's thesis in like section 4 or something. And I've actually never really talked about this in detail or depth, but you can see here that basically like S is a generalization of W, where in the case, basically like if you can spell W with S by specializing your unary function to just be identity, if that makes sense. So S has the pattern, you know, f of x of g of x. But if you set g equal to I, the identity combinator, you then end up with f of x, which is just the W combinator. You're duplicating your argument twice. So, and honestly, like implicit in all of these combinators, like you can technically spell in APL using a fork the W combinator. If we go to tryapl.org, I mean, this would be a silly way to do this, but like, you know, the easy way to spell double is just by plus W. But you could also do identity plus, why can't I spell? You could also do this, which is kind of neat, like as a mental fun exercise. And so this is basically the concrete spelling of, if we go back to this here, is like in this graph, this shows that basically anything that you can draw an arrow upwards is a generalization of that combinator. So with D2, you can spell any one of the combinators in this little hierarchy. But the W is only there if the expression is only applied to a single value and not a pair, right? Yes, but that's captured in the fact that we're saying here that this is a monadic chain. So if we are going to do this, then we currently don't process this correctly because we're ignoring this value at the moment. But once we do, this will say it's a dyadic chain, and then the way that this will evaluate, I believe, is just, actually, let's go to the table. I think it's a binary function application followed by unary function application. So I think that's going to be the B1 combinator. And if we go here, scroll down. So that's a, yes, I mean, it's so confusing because the way that works is you look for it is a 2-1 dyadic chain. So you're going to end up at the 5th slot here, and this is just function application. And then you're going to end up at the final slot here, which is just unary function application. Implicitly, though, that is the B1 combinator because that's a unary function after a binary function, which makes me kind of wonder if there should be like a 2-1 or 2-1 here, yeah. Maybe I'm thinking too, but the W is only there if the, yeah, we already read that. Maybe I'm thinking too. Yes, yeah, that's what I'm doing. And Ven's pointing out that that's what Jelly does as well. I think actually that's, yesterday when I was creating this markdown, what makes a chain dyadic? It's whether you pass 2 arguments to it. So that's a kind of a, I don't know if it's confusing about Jelly, but like all of the atoms that Jelly provides you with are non-ambivalent. They have a fixed arity. But every single chain that you create is ambivalent. And the way that you are going to process this is based on whether you're passing it 2 arguments or 1 argument. I'll be back. Time for bubbly number 2. All right. Good questions, though. So yeah, let's just spell this out. We'll encode the formula in a sec. How is grammar normally specified in highly symbolic languages? I have no idea. That would be a question for the implementers, Marshall, Adam, Kai Schmidt. If width equals 5, so if we start off with, well, you can never start off with a phi, but this is a 2-1. So if we do plus square again, that'll be phi. And then we do plus square. So this is going to be an S phi phi. So in this case, it should be 5 plus 1 is 6. But in this case, it'll be 5 plus 2. So return 2. Yeah, Sophia, I was actually thinking the same thing last night while I was thinking about this. And I don't actually think it would be too difficult. Because, right, you know that every single line is going to come from one of these numbers. And you could just quickly pre-process this ahead of time. And then you could, what I thought would be even nicer is you could color code this. So, this could be, red. This could be yellow with a yellow dotted line here. And then this could be green with a green dotted line here. Yeah, maybe we should do that. Yeah, C4 Tubo, is answering Connectidy's question. What's the easiest array language to learn? Everyone seems to be having an amazing time with Weewa. Has Weewa, have they... Weewa. Have they passed? Look at that. They've passed 1,000 stars. So I think now, based on stars, Weewa is now the most popular array language. Easier to type. Less confusing because of no ambivalence. I personally still prefer BQM better, but I'd say Weewa is like my second favorite language. But honestly, I don't think you can go wrong with any of them. APL, BQN, J, Weewa. I would just try them all, see which one you like the best. Yeah, Gainer saying BQN pad plus BQN docs and BQN crate. Yeah, I think BQN pad. Whoops, I don't actually know what that was. BQN pad it's phenomenal. When I first saw this, I was just like, for making YouTube videos, it's amazing because, I can just type stuff. I don't even know if that'll parse, and then it just automatically updates. Like I imagine the individual that created this was not thinking about people making YouTube videos, but like compared to this, where you're going 1 + 2, and then you have to go up in the expression +3. This is still nice to look at, but like compared to just having it update in place, just small things like that. And I think that's kind of the same way that Weewa works. Yeah. I also am a big fan of BQN's functional features as well. Anyways, right, we are trying to create this. So actually, let's just start with this, and then we'll do the return none thing. And this is going to be a enter none. So this is phi. So phi should always be 5. But as I guess it's plus with adjustment, and then with adjustment of W. If this works, I'll be pretty surprised. And why sigma should not be 4. Sigma should be 3, but we were just baking in that initial S sigma adjustment. Also, I was thinking about this yesterday. I don't necessarily think that this is correct at all. I think we're going to get rid of this. And then this should just be 3. And B should also just be 3. I mean, let's... what's your take, Gainer asks, what's your take on symbolic languages for scripting? I see you're using normal Python for this project, which is fine, of course. But it is, therefore... Or is it because there aren't any GUI libs? Yeah, I mean, honestly, I am a much better Python programmer than I am a APL or BQN developer. And that's just because even if I don't know what to do, I can just go and ask ChatGPT. And ChatGPT does not have good support for APL or BQN these days. And also, too, like, the fact that we were able to get, this autocomplete, like, correct me if I'm wrong, but I don't think that there is any library in any of the array languages that even comes remotely close to something like this. And the fact that I still don't even understand how this works, which is fine. I don't care about understanding how it works. I just want it to work. This is not the important part of the logic of this application. So all this stuff that got imported here, I haven't even looked at the code, to be honest. The sub process was generated by ChatGPT, but I know basically how this works, and you read from stuff and the different studs. But this completer, this history, that was just all automatically added. And it's fantastic, as a developer. I don't want to have to think about the stuff that I don't have to think about. Like, the best code is code that I don't have to write, in my opinion. And all the array languages at this moment in time don't have like a fantastic story for that. That doesn't mean I don't hope that BQN gets to the point. Like, I know that the array lib, not array lib, what do they call it? RAID lib, which is this sort of FFI-able 2D panel sort of graphics library that's being built and people are doing game stuff. Like, I hope it gets to the point where I can go and build like a Scrabble game in BQN or something like this in BQN. But also, too, like, there's something nice about having just like a super flexible, dynamically typed, interpreted language that I don't have to compile. Like, even though I am more of an expert in other languages like C++, I move at the speed of light with Python because it's just got everything that I want for this kind of stuff. Yeah, that sounds cool. Right, we're taking this for a spin. Width is not defined. Right. He says he knows Python. All right. Right, because now this is adjusted, right? So what's the formula is when it's 3, you want to adjust by 1. This one is going to be 1, 2, 3, 4, 5, 6. And we're adjusting by 1, 2. I mean, let's just keep on filling this out. It's going to be some integer division. So currently it's what? -1 integer divided by 2? That's my guess. That looks right. So then if we add another square, this is going to add a 1, which is going to be a B combinator, which definitely did not get adjusted correctly. So B got 3. Oh, I did not add the width adjustment to most of these. Which begs the question, how is that? Oh, because it was 5. 5 was the one that I did add it to. Okay, I did not restart the program. So what is this? 1, 2, 3, 4, 5, 6, 7. And 7 is going to be adjusted by 1, 2, 3. So yeah, I think we know what the formula is now. The formula is return width minus 1, integer divided by 2. And now we no longer need this none. That looks right as well. Boom. All right, what is the other one that we've done? We've done this one as well. That's pretty nice. I honestly kind of want it, you know. What if, I'm going to try something here. Because I don't like how deep it is, if that makes sense. So we are just going to do this. What do people think of that? Do people hate that? I kind of want a thinner version of these though, you know? Are there thinner versions of the box Unicode symbols here? Ah. Stop. Stop. No. These ones. Thank you. Oh yeah, we need this one too. We can just use that. No thoughts in the chat? No thoughts in the chat? Ooh, I like that. I definitely like that better. Although, what is it going to look like in... I mean, that doesn't look very good. So... if I don't know. What? Why ChatGPT? No. Why is it having so much trouble with this all of a sudden? Does that actually look lighter? No, it's the same goddamn one. Let's go to, what do they call it? Shape catcher? There we go. I think, I don't know, I kind of like the previous one better. I do like the fact that it's lighter though. And then I think, yeah, the thing to do is just to color code it and draw the I mean, another alternative, I mentioned this yesterday but didn't complete the thought, is to prefix the S in front. How hard is that to try? Indent -1. Actually, I guess we want it after, don't we? So actually indent -2. That looks very bad. Yeah, let's just leave it the way it is and add whoops. These are all identical, right? Ooh. Gotta love Python, you know? Pretty beautiful. And look, technically those are all... Look at that refactor. Gorgeous. And like, and this is, that's just so beautiful. So beautiful. I mean, you could even do what we did yesterday and put that into a dictionary and then just pass the first two. What happens if you, in Python, if you try 1, 2, 3, colon 4. Wow. So we don't even need to check the length here. Huh. Which means W equals 5 if C equals 5, else 3. so beautiful. Oh my goodness. My goodness. Look at that. Five if C. Local variable C referenced before assigned. Oh, right. It shouldn't be phi, right? Oh, whoops. That is +1 integer divided by 2. This is I guess we should print 3. So 2, 1 is S. 1, 2, 1 is phi. We print the tree and then we get rid of 3. Then we end up with 1, 1, which is B. 1, 2, 1, which is phi. 1, 1, which is B. So wait, what's wrong here? We just have a single. Actually, let's take a look at the diff here. Right. I think actually in the case where you've just got a single one, so if it's length of chain equals 0 or length of chain equals 1 and not initial call. Woo! I mean, this is so nice. This is basically the visualization of without even having to do it, you know? This is the pattern matching. Although I wonder if 2, 1 should be above 1, 2, 1. Maybe. All right, let's commit this code. And then maybe we'll add the coloring and the dotted line. Or should we leave that for now and add the dyadic stuff? I mean, what's on our to-do list? We fixed the alignment. Oh yeah, maybe we should add. Hello, hello. Hello, Sherlock Sage, aka Evan. Progress is fantastic. We have added initial support for dyadic chains, although they don't display anything. And we've, I won't say perfected these combinator trees. I still think they're a bit deep, but they align perfectly. I mean, I don't think it should actually be that hard to add. You know, everyone's famous last words. We're already at an hour and a half. Well, let's commit this for the time being. All right, we will refer to you as Sage then. Sparkles. Fixing combinator tree alignment. So mean, I'm kind of torn. What do you think? Think we should add them? All right, it's 2:26. If I can do this in less than 30 minutes, otherwise we're just gonna git stash. So we want a version of this combinator tree function do I really want to do that, though? Do I really want to do that? I mean, screw it. 30 minutes. So this would be the hackiest way to do this. And and that's actually pretty good, if you ask me. Surgical precision. Although now, and we don't even really care about initial indent. Right. Oh, it feels good. So that was easy. I shared this previous stream with friends in the Code Golf community, and they were wondering if you were interested in other types of esoteric languages besides array ones. I mean, I'm interested in all programming languages, but I have an affinity for the array ones, and it's not honestly about code golfing for me. It's about the power and expressivity that you get from these languages. I mean, I'm not arguing that this is expressive necessarily, but you could make an argument that this is no different than the APL or BQN. I mean, it's a harder argument, but like you can see like a C over top. It's easy to remember that that's ceiling. H under dot. Double. Maybe. Is that supposed to mean kind of like the inverse of half? Half being square root, I guess, because power is an upper 2 and The half glyph has it too. So, there is some, I imagine, mnemonics to this stuff. Yeah. Have you looked at Mercury? Never even heard of it. It's based on Prologue. I mean, Prologue's interesting, but it's not my favorite. I mean, already this is pretty brutal. This is Hello World. Clearly not a Kogolf language. Actually, so I tried to look at Seriously and Actually, and yeah, I can't remember. I glanced at them and didn't really pique my interest because they were derivatives of jelly. Yeah. Anyways, we are losing. I've only got 25 minutes left. But now that we have this, we can pass this along. As the, what do we call this now? We called it the chain arity. So we call this chain combinator chain combinator, CC, and that stands for maybe we should call it chain combinator sequence, CCS. So we've got, and honestly, we should, I kind of like displaying it like that, Then we should, in parentheses, put this as, and we can get rid of this to do because we already did that. So yeah, really, this is just a different way to spell this in combinatory logic combinator speak. I mean, in J speak, this is, hook, fork, a top, fork, a top. Okay, but now that we have this, we want to pass CCS along. We might need to You think Seriously predates Jelly? Interesting. I think on that APL wiki, it shows that Seriously and Actually derived from jelly, so maybe this is wrong. This is, I'm just basing that statement off of this, so I have no actual insight into it. Okay, so we're now passing in CCS, which is a string. So for W, we don't need anything. And for this, we also need to pass in CCS. CCS. And definitely this is CCS. And we're going to shave off the first one. So then when we're inside this, we're going to want to do two different things. Basically, we want to add two print statements inside here that are just going to actually okay, the GitHub shows jelly dates to December 2015, seriously from November 2015, and it was more like they were made in the same environment at around the same time. Interesting. So and actually I'm pretty sure we're going to want to cut the head off of this as well. And I guess we can just add this here. So this is going to be this times the head of CCS You saying about how I'm refactoring this right now? I mean, I wouldn't say I'm refactoring as much as I am surgically inserting. So we're gonna need def combinator width int oh, you're refactoring. So if we do this, then we do this. I think we might need to subtract by 1 here. We definitely need to subtract by 1. And then we put in a pipe, I guess we don't need that. And actually, that's only going to insert the first one. But hey, baby steps. One, two, three, four. 1, 2. Oh, right, -2. So -2, and then also I mean, these are going to end up being separate print statements anyway, so let's just break them up. I mean, that is correct. Except we want a dotted pipe. Yeah, it's JetBrains Mono. Firefont. We need another... not dotted enough. Oh, that's not what we want either, I don't think. Maybe. It's going to have a... I mean, we got to get multiple of them next to each other to know first. Okay, so we did that, but really what we need to do is we need to create... And actually, because we're going to want to color these differently, we're going to have to do this with the for loop. I was going to say we just want to generate this string all at once. But we do not for C and CCS. Ooh, that would actually, this is going to be really nice if this works. Whew. All right, so we did this once. Now we need to do it again. So we copy, we paste. And this time it's going to be it's going to be off, but all of them are going to be off. So really it's just the first one that we need to make some small adjustment to. And actually maybe the thing to do is just to modify this statement and then put this, def bars, print bars, and then after the name, it's going to be maybe. Also, what is going on here? I type Q. Can we just do this? There we go. Yikes. Yes, thanks, s.music. Why are we breaking here? Why? Oh, right. So we're off by one. I never know the operator. Ta-da! I mean, do we like that though? I mean, it obviously is better than what we had before, but I don't really like this. That's worse. I can tell this is probably going to be worse. Yep. Well, what if we just do the colon? It's still not as nice as... I mean... What do people think? I could also just use a vertical bar. So bad. Let's try that again. Nope. There we go. Damn. What do people like better? This one? I kind of like this one better. Or this one. It just irritates me that this space between the last vertical ellipses and this corner piece is not the same as these. Bothers me. But unless if folks in the chat weigh in, I think we're going to stick with this, and then that means we've got 5 minutes. Am I? Let's adjust the way we're sitting here for a bit. Now we need to move the cprint function to our draw. Go back here, find cprint, and draw.cprint. Done that. And now how am I going to do this? We want red, yellow, green, blue, and then we want them to cycle. So we basically just want some rotating index. And that's honestly not going to be too bad. Def color int. I actually don't know the type of if I equals 0. Actually, should we just I mod 4 equals 0, return 4 dot red. Do we have red already? We do a little bit. Maybe we don't want to use red. Yellow, green, and blue. Just yellow, green, and blue. Two, green, blue, and now all of these are going to need yeah. Probably we should just share the logic and create a different function to do create a different function for this. So now that we've got I, we're also going to need to pass this I to and now C print color I and true. Let's see. So actually I want plus square 10. Style is not defined. Right. Because this now belongs in the other file. That doesn't look yellow. Oh, right, because it's S. We would need it to be W. Why are we printing true? Oh yeah, what am I doing here? No, that's fine. Right. Pretty good. If we change this to half, pretty good. But now when we go back to our expression, it's not going to do anything yet, but that's fine. We are just going to C print this color I and false. Then we're going to pass I in here. I int there. We're going to pass, we're going to call this n. Enumerate this. This C print then becomes color of I plus n with a false. And we pass in I here. We pass C print here. We pass color I there. And pass false. And I'm going to be so freaking thrilled when this works potentially on the first time. Ha! Except it's not actually right. That was pretty close though. Pretty close though. I think we're going to need to do a +1 in here. Oh my goodness. 3:03, just over 30 minutes. Feels pretty good. Hello, yeah, to Brazil. Yep. This is pretty cool. Let's try something else, you know. Where's do I not have yeah. So then if we do square, that'll be B. If we do half, that'll be B. If we do plus half, that'll be phi. Just keeps going and going. Looks pretty good. I'm not sure about the colors. Should we add more colors? Lua programmer. I always get requests to add Lua to my one problem N programming languages. So cool. All right, let's ship it. If you only have 3, it might work. Oh, okay, let's I mean, it's as easy as just what do they have? 4 dot. Cyan. White. Light white. Magenta. Magenta could be good. And while we're messing around with this, n equals 4. I mean, actually, that doesn't really matter. You can change it all at once anyways. Ooh. I like that. We should kind of make a rainbow. What are we missing? We're missing orange. Although I think orange might be a bit tricky. They don't have orange. What is cyan? Should we try cyan? Yeah, I don't know how I feel about cyan. Stuart says, try these. We will indeed. That looks worse. I think that also looks worse. I don't know. What do people think? I'm going to get a bubbly. Well, folks. Woo! What do people think of the colors? What do people think of the dash lines? I'm going to eat this donut. I bought snacks today because I was starving yesterday. And don't worry, I'll show folks. Look at this donut. Freaking fantastic. Unholy Donuts, shout out. It's a Toronto-based company. Although I think they have it everywhere in Canada. All right. Here's what I'm thinking. I'm thinking no cyan. And I still like this better. That's a pretty good idea, Connectedy. I mean, the list idea is probably the best. I don't really understand what you mean by the enum. Thinking like an array programmer. Works. Oh, yeah. I didn't update my city strides. All right. Are we good to go? Get status, get add. Rough. Although I'm a bit worried. This is all going to be broken when we add dyadic stuff. And the separators and whatnot. What? Sparkles. Add colors and vertical ellipses to combinator trees. And this is the one I wanted. So now we can get this. Go here. Even better. Although maybe we should have magenta first, but whatever, it doesn't matter right now. All right, let's go back to our to-do. Hello, Brian. And let's do this next, because I think that's going to be easy. So if we come down here, we haven't added these cases, so it should be pretty straightforward. So basically, you know, this will form a S combinator. And if I add plus 10, this should just evaluate as function application. Boom! That did not work though. Right. This is a 2120, and then it should have said monadic chain. But right now in our combinator tree function, we don't have support for this, but we just want it to be an F. So it should be actually a pretty minimal change. If we go here, we now come down here. And so what's the priority? This is above 2, so 1, 2. So this is now going to be, if we have a 1, 2, 0. And also if we have a 1, 0, 2. These are both going to be F. And I think these are both going to be, they actually might be 5. Let's just leave it as 3, but I think it is 5. Anyway, so we'll run this again. right. Small mistake. Okay. Print. Oh, right. A 120 chain should pop off. Yeah. Yeah, so this is. So if C in why are we still printing? All right, did I not restart this? I guess we should just use combinator width down here. Brilliant. And now if we add 10 plus, although actually, wait. Yeah, we got to fix this though. Ooh. That's going to kind of be maybe non-trivial. Because really we want it to go from this to this. But it's character by character going through our string. And if you've got a multi-character numeric literal, then it's going to separate those apart, which is kind of funny. And so actually, so like for the purposes of making this less confusing, yeah. So a 212002 chain. So this first evaluates as S, then a function application with your niladic numeric literal plus a binary operation, and then a 102 is the exact same thing as a 120, but I guess my guess is that you're going to get some commutative properties. So if I switch this from, if we do minus first, you go yeah. One of them's 110 minus 5, and the other one's 5 minus 110. So this kind of eliminates the need for something like the C combinator. But that's basically done. Look at that. Pretty small change. And really, maybe we should call it D for dyadic function application and M for monadic function application. That might be a better idea. Absolutely, go for it, C420. Although, wait, is that like downgrading stuff or what? I don't know. Well, submit the PR. We'll take a look. I'm happy to make changes as long as they're not obstructive. So this should be M, and then I mean, in the subsequent case, it's definitely D. I think it's D here as well. But let's just go check, right? So if we have 0 plus right, technically that's going to be a 2002. All right, 1 second. I gotta do something. All right, we're back. Right, so call this D, call this D. So yeah, this is yeah, it's kind of interesting too, because I wonder if this is like the LCC, the leading constant chain. But I think my like algebra just deals with it correctly. I'm not sure if there's some other special case, but yeah. So if we go back to our README, so M is monadic function application. D is dyadic function application. And should we get rid of, or should we keep? Let's just keep it. So this is a monad. This is a dyad. Actually, I have that backwards, don't I? Dyad. Monad. We can come down here. Ooh, and it's not F anymore, is it? It's MD. Actually, wait. Sparkles adds support for 2.0 and 0.2 monadic chains. All right, back to the to-do. This is done now. All right, so now we are basically just on to adding support for dyadic functions. So actually, wait, let's go take a look at, is there a PR? There's no PR yet. So yeah, let's just go. So if I want, I mean, yeah, what was the example, right? Right. It's not how I spell things in Jello, is it? It's this this div half. This is a 2221 traceback. So if we go to our table, and this is the special rules, right? Actually, if we go down to so with 222, you end up with hello, Fazlul. Sorry, I keep getting distracted. A 222 train. PR submitted. Should we just go look at the PR then? 222 train ends up being the phi 1 though. So should we actually let's go check out the PR. Otherwise we're just gonna end up in merge hell. What I need is some more caffeine, which I'll get in a sec, but... I mean, I'm not sure. I like this because it works. You're just adding the ability to have no colon. Yeah, I mean, but that's the way. I think I would rather just like add a. Well, I mean, we'll merge it, but then I'm going to change it immediately. So I have an alternative solution. COO. Well, no, I think it crashes for me too. Is the issue, you know? You get rid of this and it crashes. But I mean, there's a ton of ways you can crash this program right now. I have not built any resiliency into this. So let's just do that for the moment. And don't need a label. Confirm merge. Come here. I still like this better. If oh. What did we do here? we should say async colon thanks for tuning in. Be back in a sec. So I'm not going anywhere. I think it's just C for Tubo who's checking out. And now I just realized an oversight on my part of how all this was designed. The phi1 is a 2 character. It's gonna mess everything up. So let's see if that works though. Ooh, it's really gonna mess stuff up. So this now needs to be a list. Come on. So does that make sense? 20 where's the ooh, yeah, because it's gonna build a binary function though. So we did another function called def comp arity. And if C equals phi1, return 2 if C equals comp1. Else 1. So now this is comp arity of C. How would, is there, here, let's go ask ChatGPT. Is there a way to format a single line of Python in VS Code? I guess I could have just format line. Let's see what. Shift Alt F. install formatter. Which one should I use? I mean, it's already installed, so. Shift-Alt-F is the whole document. Let's take this question to Google. I mean, Rough already has a. CharlieMarsh.rough. The heck? Not understand. Screw it. We don't need this. The thing is, all Python formatters suck. I mean, most formatters suck. Because I want my tabular data. But this is getting a little bit, unwieldy. So I want something that'll automatically do this, Actually, we can just do so this becomes plus divides with times in the middle. So 20 plus 20, or no, 10 plus 10 is 20 divided by times 1. And then half right, because it's doing S and we don't want to do S. So we need another one of these called should we just copy and paste this? Or do we put it in a file called common utils? Because it's the best language for getting stuff done. So in this case, S if chain type equals chain dot monadic else B1. Oops. Oh man, so brutal. What is brutal here? Because we've added these now 2-character. My string of combinators no longer works, of course. Right, so we need to turn this I don't think that was enough. Closer. Oh, yeah. Let's go fix that. Yeah, this definitely needs a different function now. Or actually, this should just be empty. There we go. Although, why is it still 40? let's go back to this. So 10 plus 10 is 20 times 10 divided by 10 which is 1, which is 20 divided by 2. Oh, right, because we actually haven't handled this. Duh. So if we come back here, when we call run jelly, we're just passing args1 in. So, I mean, we could pass all of the args in. Yeah, I think that's just the easiest thing to do, right? Is that? Are you able to do that? I'm not enough of a Python pro. I mean, we'll try it. Yeah, you can't do that. Can you do that? Turns out you can. And now we have exactly what we wanted. So, although is it in the intermediate? Right. So plus should definitely not be W. In this case, it should be D, lowercase d. So yeah, 2-2 chain. Or this is just a 2. Oh yeah, so we're in this case. It's technically, this is a bug. This should be M. And this should actually just be C. So this is if chain type equals chain dot magnetic. Else C, I think, is just always going to be D in this case, right? So that's D. And then when we switch this to times, that's a 2-2 train. What is a 2-2 train? It's a dyad, which is this eta combinator. Which doesn't actually exist. We just made it up because it's the analog, I think, of E. But let's do eta first. Let's see what happens. Yeah. Actually, we don't have 2-2. We don't have 2-2. 2, 2. Does that evaluate correctly? So it's going to be wait, isn't this just the 2, 2, 2 train? No, this ends up being 10 plus 10 times 10, which is, yeah, this eta thing. Although, maybe it actually is E. Because this is the multiply and this is the 10. This is E. No, so I don't, we'll come back to this one. But 2, 2 is E. I don't know why that's so complicated. And then when we add div, this is when it becomes the phi1 combinator. And when we add half, this is when we add the b1 combinator. So now what's cool is if we get rid of this, that's going to break for the, so it's not actually going to work because it's going to, How would we expect this to parse in the monadic case? This is supposed to be 10 plus 10 is 20. And then, so it's supposed to be W, D, D, F. Right? Because, yeah, that's 10 plus 10 is 20, times 10 is 100, divided by 10 back to 20. Although this then becomes S, so it's actually WDS. So, I mean, this is going to make this look very ugly for the moment. So let's see what happens when we do this. I mean, definitely shouldn't be E either. I guess it's actually the very top priority thing. So we can actually momentarily get rid of this. And at the very top, if chain 0 equals 2 and chain type equals chain.monadic, then C equals W. That didn't work. Why not? Oh, right. Combinator arity. I mean, it is 1. is going on here? If chain... What the heck is going on here? I'm so confused. Oh, wait, so we're not actually making it. No, we are. But then somehow this gets reset. False. What? I am so lost. So somehow, do I need parens? So we've got we've got chain dot monadic, but they're not equal to each other. What in Lord's name? I mean, this should work, so I don't know what the problem is here. Oh, is it because we're passing? I mean, why? So what if we do this? So the fact that we have copied this is a problem here. All right, so let's... Are you allowed to do like cyclical things? Why is that? What the F is going on? Well, let's just see if this will fix it. Actually, no. Well, that fixes it at least. So I think Hmm. So this is put my hoodie on here. This is a 2221 train, which is going to evaluate 2, 2, and then 2, 1. So the 2, 2 gives us 10 plus 10 is 20 times 10 is 200. And then the 2-1 train is 200 divided by 10 halved, which actually is not the it's not the S combinator, which it shouldn't be because it's not an array language that uses emojis, no. How does this work, though? 2... A 1, 2 is... 2 is W, and then a 1, 2 is sigma, I guess. Which I changed it so it didn't do that. So let's get rid of this. I don't know why that's D now. Oh no, W is still combinator width. No, combinator arity. This is the thing. This should just be 1. So W... It's not W sigma, though. It is... I mean, it actually is sigma. W is the unary function. W creates the unary function that is then used in the sigma combinator. And sigma is a unary function. And maybe this is actually correct. If sigma, which is what calculates... Man, this was right from the beginning. Wow. Frickin' epic. So sigma is formed using the function created by W, which forms a unary function, which is going to be the left function in the fork, which is going to give us the value 200. And then half is going to be our right function, and then divide. Wow. Didn't even need to do anything. That's really quite amazing. So now the question is, because we handle W down here, do we need to hand it up here? I think there's a chance, you know, to do. I think we can. Um, 21 errors fixed. Jeez Louise, what did I do wrong? So this was the dyadic example, which is definitely correct. I mean, that's really phenomenal. We should we need to add that stuff though. Pretty crazy. I mean, let's go back now to our table. Also, oh yeah, I guess B1. So how does this work? If we've got a binary function, so this is going to be the B1. Okay. That should put a binary function on the stack or on the chain. So if we do plus times, it then should be (1.5) plus 1 times 2 is 3.5, which is the phi1 combinator. The phi1 combinator is a binary function, so that puts a 2. So then if I put something like square, that is going to be the B1 combinator again. So now this is where it gets interesting, because I don't think I have, so if I do plus 1, that should just be dyadic function application. So it should be a D, but it is not. Because what do we have? We have B1, which is a binary function. And therefore you end up with 220. So really this should be, oh, so beautiful, so beautiful. Needs pattern matching. Yeah, it would make it nicer, I guess. We end up with 1, 0. Because we end up with 2, 2, 2, 2, 0. How many does D? W. Combinator width. So D is 5. Two one puts a 2 on the stack. So then it should be 2 2 0. 2 2 0 is. But then you end up with 1 0. Why is that? 2 2 0 should get reduced down. To a single element. Oh. I mean, B1? I don't understand. So you end up with 2 2 0, which is gonna be D. I mean, let's just check that. It's E. Why is it E? Ah. So I just haven't actually parsed this right according to the table. So this becomes 12.25 Yeah, this just becomes +2. And then you end up with a 2, 0. Although it's 2, 2. I guess the problem is here. I don't actually fully understand this, but E. I mean, E's technically. Is it E? I mean, what happens if we just get rid of the 1 and remove all this noise? So B1 forms a binary function. So this is the phi one, actually. I mean, I don't actually know for sure. think maybe on the initial call it's E, on subsequent calls it's phi1. Although I don't actually know. What is already phi1 though? 2, 2, 2. I mean, no, this is we're back to where I was before. Where did Ada go? Or is it epsilon? Whoops. All right, let's fill some of this stuff in because I'm confusing myself here. So 2, 1. On subsequent calls, this is the B1 combinator. On an initial call, I mean, what do you get if you do half of 1020? Returns you 5. Why? Is there any... Yeah, we gotta go back to Otherwise, we start from v equal to lambda. Okay. So if v is equal to lambda, then we just throw the second argument away. So how did we get there? We got there because technically it's monadic function application after like the ki combinator, where it's k plus m. So yeah, this is epsilon. What happened to epsilon? Didn't I have an epsilon? Yeah, we put it there. And also, on subsequent calls, is this really B1? So we've got plus 1, 2. We square this, this becomes B1. makes sense. That checks out. And then if we add a binary function here, that's going to be a two chain I mean, what is this? This is yeah, I guess, yeah, equal does take two binary operations. Eta takes two binary operations as well. Let's go update. Let's go do that right now. I'm going to move some stuff around too. So I mentioned this at the top of the stream. We're taking Starling and it's going to come down here. And then we're going to add epsilon, which is going to be the following. Ooh, we're going to need another eagle. The golden eagle. The golden eagle it is. I fill that in at a later date. I don't think there's any support for this, really. And then if we're going to do that, I should be at the top. So although I'm still not convinced. Let's go back to so I think technically this is actually a 2-2 train. But V is the result of the application of a binary function. So really it's a so this is it's a phi. So what is this? This, you know, plus squared equals ends up being a binary function. And then plus is going to get used again, and then right is going to get used again, which is going to give us, you know, the 1 plus 2 squared plus, and then we're taking 2. So technically 2, 2. So really this is epsilon. And this is what, on subsequent calls, a 2, 2, 2 is going to be a phi 1. And I think it's even a phi 1 on the initial call, which then this is consistent. Right, so let's go back here. So does this make sense now? We end up with a binary function that's going to be applied here. The second binary function is plus. And I guess the catch is that there's this ki, or right function, being applied. So it's kind of just arbitrary that in this table we ignore lambda and take rho. This is like a very arbitrary decision. So actually, you know, if we come here, this is not E or epsilon. Like this is a specialization of epsilon where D is equal to E. So really 2, 2 is like, you know, epsilon prime or something like that. That's what we're going to call it. And epsilon prime does indeed have an arity of 2. Yeah. And so what happens now? So now if we, instead of ending with a 2-2 chain, change this to a minus, this becomes a 2-1, 2-2 chain. 2-1 forms the B1, which yields you a binary function. So then you end up with a 2-2-2 chain, which is going to be the phi1 combinator. And if I have to do that math in my head, you're going to end up with 9 plus 1 minus 2 is 8, which is correct. Okay. So yeah, what is on the initial call, plus is just going to be dyadic function application. Right? So if we go +2, 1, 2, and that is consistent with this because of that. Okay, so we got D there. F is going to be MK. So if we go square, it's just 1 squared. It's going to make this 10. It's going to be 100. So I think this is where this will be epsilon and this will be E, which currently aren't encoded. So this is going to be 2, 2, 0. So wait, this is wrong then, right? And this is going to take higher precedence. So this will be, and E will be 0, 2. Epsilon will be that. So what does that mean? So that's dyadic function application. If we follow it by a square, that gives us the B1 combinator, which is going to give us a binary function. So now if we go +1, this is going to form the epsilon. It is not happy. 220. Two, 2, 0. Right, the issue... We're probably going to end this in a couple minutes. We get 220. And I guess we need to add, yeah, epsilon and e. That's why. And I think they also need to go up here. They do indeed. Now the question is, can I get the same result? Although, what's going on here? One plus 2 is 3, squared is 9. Then we have plus, which is going to plus the 2 is 11. Right. Looks like it's negation. It's just subtracting 1, but you're going from 9 to 10 actually in this expression. And so when we do the exact same thing, we should get 10. And plus squared 1 ends up being a 2-0 chain. I'm not sure if that's right. What happens when you hit a a 2-0 is what is D. So this would give us 9. But then the 9 is just juxtaposed with a 1. I mean, there is no... Let's go back to the README. This is a 2-1-0 chain. I honestly have no idea. So a 2-1-0. Let's walk through it. 2 is going to hit this, so that's just applying. Which gives us 3. Makes sense. 9, or square is a monadic function, so we just apply that. But then we get a 0, or we get a nil add. Or actually, wait, so yeah, 2, 1 becomes 2, 0. What is 2, 0? That's not really how this parsing table works, so. I mean, what is 91 is 9 squared. Let's go to that jelly balls or whatever that site is. See what it has to say about this. So if we go, actually let's just copy it. We go this. 1, 2. Come over here. Wait, I have a theory. Is this going to be 911? Okay. So a 2, 0 doesn't even make sense. It's not even anything. It is concatenation of numeric values. Sure. That doesn't make any sense at all. But we'll put it at the very bottom. Also, and actually, let's, while we're at it then, if we turn this into a monadic function, because I don't think, we don't have any 1 zeros either. So if we end up with square is just monadic, and then if I put a 1 here, yeah, it's also just 1001. Interesting, interesting. So we're going to call this C for concatenation. Ooh. Except that should have been MC. Is it? Yeah. How do you handle that? And actually, and so what is and this is a 2, 0. Is it not? Or is it because I just have a two-digit number? No? Oh, is there? Because there's 2, 0 up here. Are these even supposed to be there though? So I guess it's and not. Ah. Got it. All right. We are going to call it there. We still need to fill out some of this stuff, but overall pretty good. What we need to do, though, this is fine for now, just like this. All right. Thanks for tuning in. We will maybe do this again in the future. Yeah, this stuff definitely we need to sort out, and we need to get the multi-chains. Until next time, though, thanks for watching.